Today we will be discussing about soap and detergent industry. This is the second chapter of industry that we are discussing from the last class. Last class we discussed about oil and fats industries. Today we will be discussing about soap and detergent industry. At first, I'll be briefly introduce what is the soap and detergent. Um, Soaps and detergents are cleansing agents. Generally, when we do the washing of our clothes or any kind of washing related activity we do, we use the soap and detergent. Usually, there is a huge difference between soap and detergent. We will be discussing about the chemical properties and structural properties. What is difference between soap and detergent? Those all will be elaborately discussed in the future slides. Soaps are the sodium and potassium salts of long chain carboxylic acid. You have to focus on that soaps are there is one long chain of carboxylic acid. So there is the head, that is the hydrophilic head, that is the carboxylate ion. A soap molecule consists of a long hydrocarbon chain that is generally hydrophobic in nature, that is non-ionic in nature, with a carboxylic acid head which is ionic bonded to the metal ions, that is the metal ions that can be sodium or potassium. So that carboxylate ion that is at the hydrophilic head, and there will be one long hydrocarbon chain that is the hydrophobic tail. You can see from this structure, this is the kind of tadpole like structure. This structure is like this kind of tadpole like structure. Okay, and there will be one head. Okay, so this one is head. Let me feel it. It will be easier. Yeah. So this one is head, whereas this part is called this part is called tail. Okay, what is happening? Okay. So this is one kind of tadpole structure. This head, this is the representation of the head. That is the C. Here is C double bond O O. So this is kind of negatively charged head. Negatively charged head group, which is a short ionic part, and it is hydrophilic in nature as well as polar. So this polar part is they will attract the non-polar part. Okay. Whereas this long chain hydrocarbon, there will be multiple CH N. There will be multiple this kind of chain will be there, and that will be hydrophobic and non-polar in nature. So overall, this soap structure is a tadpole-like structure. Some examples of soap are sodium stearate. This is the sodium salt. This is the sodium salt of long chain carboxylic acid. Sodium palmitate. This is another kind of fatty acid that is being used. Sodium oleate. These are some typical examples of soap. Presence of the hydrophobic and hydrophilic group that helps to alter the surface tension and the wettability of the soap and detergent activity. So how this soap and detergent alter? Generally, it reduces the surface tension. Reduces the surface tension. So how it does, we will be discussing. Soaps are not suitable to be used in the hard water. Hard water means there will be lot of Ca2 plus, Mg2 plus ions. There will be lot of this kind of ions, and because of this presence of these ions, soap will form as precipitate, and for that the foaming activity or the creation of the foaming will be lesser. The actual purpose of using the soap will be reduced when it will be used in the hard water environment. They are very weak cleansing properties than detergent, but detergent can there are some mechanism that they do the replacement mechanism of the ions. For I'm talking about the detergent, they do the replacement of ions so that they detergent can act better than soap in a hard water environment. Next, that I'll be discussing about base driven hydrolysis. Why the hydrolysis is required? Because we know that triglyceride, when it will be, the triglyceride, it will be hydrolyzed to get glycerol plus salt, or generally glycerol plus fatty acid. Let me call it. Generally, it forms glycerol and fatty acid. Okay, so when it is hydrolyzed, hydrolysis reaction occurs and it forms glycerol and fatty acid, primarily fatty acid, primary product. Now these fatty acids are reacted with some NaOH so that all that forms salt. Okay, let me give you the structural example. What is the structure of a triglyceride? We already discussed in the last class. C double bond O. Let's see, it is R1 CHO, R2 CH2O, C double bond O3. So this is the triglyceride, that is either fat or oil. Okay, so it will be reacting with NaOH. We are discussing about the production of soap. So this is the strong base we are using, NaOH, that reacts and it forms the backbone. It separates out the backbone and it forms glycerol and it forms salts. Salts, it separates out C double bond O, O, Na. One salt, second salt is C double bond O, O, Na. Now third salt, it separates and it will be like this. So these are the salts that is produced by reacting with the base, strong base. And this is the glycerol, this is the salts, and this is the triglyceride. So basically initially it was fatty acid. When it reacts with NaOH particularly, then the um, H will be replaced by the sodium ion and it forms the salt. And that is the soap. Now let's discuss about what is the mechanism, how the soap is reacting with the oil and grease, like what is the cleansing activity. Okay. First, let us uh, let us assume this is the water environment. Okay, H2 molecules or H2 atoms are there, molecules are there. So water dissolves polar compounds. So in this is the soap structure. So this is the tail end, that is the hydrophobic, and this is the head, that is the hydrophilic. Okay. Now oil. Now it is written that water dissolves polar compounds. Oil and grease, these are non-polar compound. Soap acts as an emulsifier. What is that? Emulsion. What is emulsion? Emulsion is the oil droplets that will be suspended in water. So how that acts? It is like, first, the non-polar end, that is the tail end, will be acting on the oil and grease surface. Suppose this is the your oils, the oil droplet is present on a surface. Okay, So oil droplet is placed in on a surface, and we have to remove that oil droplet using the soap. Now, when there will be addition of the soap, the uh, obviously the hydrophobic end will be connected to the hydrophobic ends of the soap will be connected to oil particle, and the head group of the soap, which is hydrophilic, that will be attracted to water environment, because it is hydrophilic means it will be attracted to the water environment. So the position will be like this, and when it gradually with increasing the with increasing the concentration of the surfactant or soap, the oil particle or the oil droplet will be completely covered by the soap molecules, and it detaches from the surface, surface. Then it looks like this oil droplet will be completely covered by this soap molecule, and it forms a missile. Okay, and it will be detached from the surface. These are the head groups of the soap. So what happens here? The hydrocarbon tail, or the non-polar hydrophobic hydrocarbon tail, those are embedded into the oil particles, and the polar hydrophilic heads face away from the grease particle of the oil particle and help to suspend the oil particle after a certain concentration of the soap molecules. It will be helping to get detached from the surface, and it will be completely surrounded by the soap molecule, and it will form a missile. So when it will be detached from the surface, suppose this surface is your cloth, dirty cloth. So by this addition of the soap, the your ultimate goal is to remove that oil, or the oil particle, or the dirt, any kind of dirt particle from your surface of the cloth. So it will be such way, it will be detached, and it will be remain in the water environment. So by cleaning that water, you will be cleaning ultimately your dirty clothes. So this is the way soap or detergent acts. Now I discussed about that soap activity or the detergent activity, they do the lowering of the surface tension. The main purpose of the surfactant, these surfactants are both used in both soaps and detergents. Okay, so these surfactants, these are used to decrease the surface and interfacial tension and stabilize the interface. Now you can see when there is only water environment, so there are some water molecules are present. This is the surface, this is the this is the air and this is the water. Okay, so on the surface the water molecules have very strong cohesive force. So there will be initially a strong cohesive force between two water molecules. Now when you will be adding surfactant that has hydrophobic tail and hydrophilic head, what it does, that you can see that there will be inter uh, that's head, a hydrophilic head that will be interfering between the cohesive force or the cohesive force between the water molecules, and you can see that F1, that is the force directed towards the bulk amount of the water molecules, that F1 was larger than F2. So by incorporating the surfactant into the system, you can see the cohesive force or the force between two water molecules decreases, whereas this net force F2 is less than F1. So the surface tension decreases. So that's way you can see that surface tension decreases by the addition of surfactant. We already discussed we already discussed about how it forms critical missile concentration. So critical missile concentration, this is a very uh, important factor that you have to take care when you will be adding surfactant to some solution or to make a solution of the surfactant, and you want some desired activity by adding the surfactant in the solution. So you cannot add more and more surfactant, and it will form and it will act as a uh, very good. There will be loss of surfactant if you add unnecessary surfactant. So if you know what is the critical missile concentration, so you can add the surfactant just above the critical missile concentration, and you will get the similar desired output that you want to get by adding the surfactant. Like by this graph you can see in the y-axis there is surface tension. In the pure water system, pure water, there is no other external molecules, there is no molecules of the surfactant. So the pure water, the surface tension is around 70, it's very high. Okay, now when you will be adding the concentration of the surfactant, and it will be increasing in this direction. So when you will be adding the more and more amount of surfactant, the pure water surface tension will decrease till this phase. In this region, that will that will be in the zone of monomers, like separated molecules. But when it reaches to this particular point, you can see that the surface tension of the water remains constant. Even if you are adding more and more concentration of the surfactant, it will not decrease further. So, if you know this value by the some experiment, laboratory experiment, you can easily calculate the CMC value of any particular surfactant, and you have to just add just 10 to 20% extra of that surfactant to get the desired output. You don't have to add more and more surfactant. It is not like that. So, when it crosses the CMC value or at the CMC value, it forms the measles. And when it forms the measle, then uh, it the water surface tension becomes constant. It is not decreasing further. So surface tension decreases with the increasing surfactant concentration up to the critical missile concentration, that is the CMC, where the concentration dependence is nearly constant above CMC. So if you are not getting desired output or desired cleansing property even after CMC is achieved, then you might have to replace that surfactant with another surfactant. Those have something better structure or better properties that can offer you more cleansing property according to your desire. Now let us discuss about chemistry of natural soaps. Natural soaps, that indicates that you are deriving the soap from the using the vegetable oil or the natural resources like animal fats. Okay, so first is soap is formed from base driven hydrolysis. We already discussed that using the strong base like NaOH, we are producing the salts of fatty acid. So first triglyceride or the fats or oil. So these are hydrolyzed. They form the glycerol plus fatty acid, and in presence of the NaOH, that forms salts of fatty acid. So we already discussed in our last class that how the triglyceride looks like, and it consists of fatty acid and glycerol, where glycerol is the backbone of, we generally call glycerol is the backbone of the triglyceride. So, in a nutshell, soap is chemically defined as the alkali salts. Alkali means it can be sodium potassium salt of fatty acids. Any cleansing agent, you can soap or detergent, regardless of its chemistry, is considered as a soap. Soap can be this source can be various resources can be there. So any kind of cleansing agent, that is we generally call this as soap. So there is particular term that how the soap is being manufactured. It is manufactured by the saphonification process. Saphonification process involves the transformation of the triglycerides, that is fats and oils, or the fatty acid, that is the after being hydrolyzed it will form fatty acid, and transformation of the fatty acid into corresponding alkali salt mixture of the fatty acid. There are three different methods that you can approach for the saphonification process to produce or manufacture soap. First one is the direct neutral fat saphonification. Second one is fatty acid saphonification. Third one is fatty acid methyl ester saponification. Let us discuss one by one. First, we will be discussing direct neutral fat saponification that we already discussed. We already discussed that how this saponification is done. First, the hydrolysis, and then it is treated with alkali solution or the alkali, strong alkali. Then it forms the salts of those fatty acid. Again, um, so before this fat saponification, we need to get the fatty acids. Okay, so that is we get by the hydrolysis process. So overall, this direct neutral fat saponification process, I am again explaining CH2 COOR, some triglycerides that will be acting with NaOH that form 3R. Okay, if you do the R, let make it very general that this is RR. This is simple R. So you will form COONA plus glycerol CH2OH CHOH CH2OH. So this is only the soap, and this is the glycerol or glycerine. This is the triglyceride, strong base. Okay, so with the salt, this will precipitate, which is being separated then from this mixture, and that will be post processed like washed and drying, and other post processing should be there. Next method is fatty acid saponification. So in this fatty acid saponification, the same kind of that we get the fatty acid in the presence of the strong base, it forms plus H2O. So this is the soap. This is the fatty acid. Direct we are putting the base, and we are directly converting the fatty acid to soap. The main source here is not the triglyceride, it is the direct source of fatty acid. The third one is fatty acid methyl ester saponification. So, just to make sure that we have discussed earlier, just we have discussed the one direct neutral fat saponification process, and another was the fatty acid saponification process. This by these two processes we actually obtain fatty acid content up to 63 to 75 percentage, And finally we get the fatty acid after drying we get up to final mass of 78 to 80% of fatty acid content. And these two processes, one and two methods we have discussed, so these two processes majorly have the 95% of the world soap production. Okay, now the third one is the fatty acid methyl ester saponification. For this, we need a methyl ester as a raw material. Before, in the first, we that was the fat or triglyceride, the raw material. In the second method, direct fatty acid is the raw material. And in the third method that we are going to discuss now, we need a raw material of methyl ester. So how this methyl ester is formed? Where from we will get? We will get this by simple esterification reaction. So let us first discuss what is the esterification reaction. So this is the condensation reaction between an alcohol and carboxylic acid. That is carboxylic acid. This one is carboxylic acid. We add an alcohol, and from this reaction we will get ester and water as a byproduct. So how this react? This will get out of the system and this will form ester. So this is the what is that carboxylic acid, and this is alcohol. Okay, so in the case of this fatty acid methyl ester, let's another color. So in this saponification method, what will be there? There will be such kind of methyl ester will be there, R C double bond O CH3. That is the methyl ester. We have to use again the strong base. It will form this soap. Ultimately, you will get this soap and methanol. So there you need some catalyst in this process. The process of esterification, you need a catalyst to get this ester, and there will be fatty acid and methanol. By this process, this methanol will be useful in other chemical industries. So this is a very good source of methanol as well as soap. Let's discuss about components of natural soap. There are various components that you have to add while maintaining the certain properties of the soap before going for the selling of the soap. Okay. First one is, in addition to the cleansing properties, color and odor, which are always thought of as the main attributes of the soap, other qualities have to be taken care. Just like one is the foaming performance. In performance, that is how much the amount, quality, density, and stability of the soap that should be experimentally you have to take care of the thing that how much foam is being generated. Second one is the skin compatibility, that what kind of oil or other thing you have to add while manufacturing the soap so that it reach up to certain benefits, it gives certain benefits to the customer or end users. Soap bar texture, soap bar erosion rate, or the bar wearing rate, the chemical stability, odor, color, rancidity, and efflorescence. Physical stability, that is the cracking of the soap bar. So these all rinsability from skin and bathtub. So these all things you have to take into consideration while manufacturing the soap. The type of alkali used in the formulation of soap determines the hardness and the solubility of the finished product. Sodium soaps are known as hard. When you are using the NaOH, you will be ultimately end up with producing sodium soaps. Those are hard in nature. While potassium soaps that has greater solubility in the water, so these are you can call soft soaps. Potassium soaps are widely used in liquid and soft soaps. Triethanolamine soaps, they have very low pH because less alkaline nature of the cation, which allows the formulation of mild transparent soap. One toilet soap example, that what are the ingredients it has: cleansing surfactant, it might be soap or synthetic detergent. This range is up to maximum. Moisturizer, glycerin or lanolin in this range. Super fattening agent, example like fatty acid, zero point 0.5 to 3. Bar hardening agent like NaCl, salt is there, zero point 0.3 to 2. Fillers are there like a starch. So this is 0 to 10. Antioxidant or preservatives you also have to use, just like butylated hydroxytoluene. It is zero point 0.1 to 0.5 percentage. Chelating agent, that is EDTA, zero point 0.1 to 0.5. Whitening agent like titanium dioxide, zero point 0.1 to 0.5. Deodorant, some fragrance or perfume should be there, like triclosan or trichloro. Deodorants, trichlorosan or trichlorocarbon, fragrance, dyes, pigments, and water. These are some composition of natural soap. The commercial triglycerides used for soap manufacture are animal origin, just like a source of fat and source of vegetable oil. So the soaps are biomass based, you can say. The final performance is determined by the length of the hydrophobic fatty acid moiety, saturation extent of the fatty acid chain, number of double bonds. It is also very important factor, and the fatty acid distribution and the composition of the triglyceride. So these all factors play important role for the final performance of the soap. The alkali pH of the natural soap is produced by the hydrolysis of soap in the aqueous solution, by which a quantity of alkali will be released, because in the formation of soap we used the NaOH or KOH, this kind of alkali. So by hydrolyzing the soap we will be producing alkali, and that pH will be around 10 to 11. The pH is further increased by the residual amount of alkali that is retained in the soap during the manufacture. The high pH of the natural soap is the cause of negative effects, including the dehydrative effect or the skin irritability. Some skin irritation problem it causes because of the high pH of the soap. Natural soap do not form foam in the hard water or the salt water. That motivates the invention of the synthetic soaps or the synthetic detergent. Now, behavior of the natural soap in the hard water. See, in the hard water, there are ions like Ca2 plus, Mg2 plus. So what it does, suppose your soap molecule it acts with Mg2 plus. So it will form some precipitate. If it is similarly, so this when the water is very hard or contains high level of these electrolytes, the foaming performance of the soap seriously reduces. The insoluble salts, these are some insoluble salts um, precipitate on the surface, and these are called scum. These precipitates are called scums. Now let's discuss about the continuous process of soap manufacturing. First, we have to produce the fatty acid, and the glycerin by hydrolyzing the fat or oil. So, the fat in presence of the catalyst, they are being introduced by mixing, they are introduced in the hydrolyzer. In the hydrolyzer, there is 230 to 250 degrees Celsius and very high pressure of 40 to 45 atmosphere. Hot water is present, it's circulated to maintain the temperature. So from the hydrolyzer, the triglycerides or fat is being hydrolyzed into fatty acids and 15 to 20% glycerin mixture, or this is also called the sweet solvent or the sweet mixture. It is the glycerin, and this is a very important source of the glycerin production. This is the natural way of the glycerin production. Okay. This fatty acid is further sent to the steam flash tank, and from that the steam is being flashed out, and the crude fatty acid is introduced to the high vacuum steam. So this vacuum still the from the crude acid mixture, the it will be distilled, and the waste will be discarded, and the fatty acid mixture will be sent to the distillate, and there will be purified fatty acid, and that will be sent to the high speed mixture. So in the high-speed mixture, this is the process of saponification. So we will be adding the alkali solution, that is NaOH, and from that there will be production of soap. In the blender, there will be a blending activity will be done, and this soap will be in various form. It will be processed or delivered, like bar stock press type soap, or the chipping rolls are there, or a spray tower, spray dryer type. There the soap powders are being formed. So these are the section. This is the section of saponification. This is the section of fatty acid purification, and this section is important for the glycerol or the glycerin production. So these are being 15 to 20% glycerin is being passed through the ion exchange. There will be three ion exchange setup will be there, and then there will be triple effect evaporator. Triple effect evaporator, uh, steam will be evaporated, and fluid glycerin you can take out from the steel. It will be again steamed, and by this process here you will be getting 99% yellow glycerin, that is only for the industrial purpose. From this holding tank, if you want to use the normal not industrial purpose, in the normal use also, then you have to decolor it by adding the activated carbon in the packed bed adsorption column, and then there will be some filter press to separate that activated carbon from the glycerin mixture, and there at the end you will be having white glycerin. So um, in the process of this saponification and in post processing, there one antioxidant agent is used, that is the sodium silicate. So this with the help of sodium silicate, it increases the durability of soap, and also the hardness of soap, prevents rapid drying. Now we will be discussing about the detergents. Okay. First one is detergents are sodium salts of long chain benzene sulfonic acid. You can see the notice. You can notice the difference between the soap and detergent. See, this is not the carboxylic acid anymore. This is the benzene sulfonic acid. Sodium salts of benzene sulfonic acid. Detergents are better promoter for lowering the surface tension than soap. Examples of detergents are sodium N-dodecyl benzene sulfonate, sodium N-didecyl sulfate. So these are widely used detergents. Detergents acts very different than soap in a hard water environment. Detergents may react with hard water ions, but resulting products are either soluble or remain colloidal form dispersed in the water. So thus detergent is very better in hard water environment than the soap. Next is detergent molecules can aggregate in water into spherical clusters, that is called micelles, and hydrocarbon parts of the molecule gather together on the inside of the micelle and the polar groups will be at the outside. So you can see this is the hydrophobic tail. Okay, this is the hydrophobic tail group, and this one is the hydrophilic head group. So this is a soap. What is the sodium stearate? And this is the anionic detergent. This is the anionic group. That's why it is named as anionic detergent. Example is sodium 4-dodecyl benzene sulfonate. So if we compare the structure of the anionic detergent and the soap, we can see that both the salts of sodium contain a long chain of the hydrophobic tail and a negatively charged hydrophilic head. This is also negatively charged. However, this is soap, so this negatively charged head group, it is due to the carboxylate ion, and this negative head group, this is okay. I can write it here. This is the um, sulfonate head group. This is also anionic in nature. So you can, this is the comparison of soap and detergent. Types of detergent, as we see in the earlier example, we took the example of anionic detergent because of the presence of the anionic or anionic head group. There might be anionic detergent, cationic detergent, non-ionic, as well as amphoteric or amphoteric or zeoteric detergent. Okay. So anionic detergent, these are negatively charged head group. It has like sulfate ion. Example, sulfated fatty alcohols, sulfonates, sulfonated esters. Cationic detergent, where it will be having positively charged head group, just like tertiary ammonium ion. Example is quaternary ammonium compounds. Non-ionic detergent, no charge on the head group. It produces very little foam, but it possesses very excellent soil removal characteristic. It doesn't form foam too much, but it has very strong cleansing property. just like alkyl, aryl, ethylene oxide derivatives, aliphatic polyhydric alcohol esters or fatty acid amides. Amphoteric so have the deuterants within the specified pH range and both the positive and negative charges within the same molecule. So uh, the number of positive and negative charges in the same molecule, so there will be net charge will be zero. Okay, so this is one example CHAPS. So this is one example of amphoteric detergent. If that non-ionic detergent, that this amphoteric detergent, it can both act as a ionic or anionic or cationic detergent. But this non-ionic detergent, just like how it acts, you can see if this is the structure of the surfactant, there will be OH group at the end. Okay, so this present of the O molecule, that will form the hydrogen bonding with the water molecule. And it also participate in the hydrogen bonding with water molecule. So by this non-ionic detergent is showing very effective cleansing property by creating this hydrogen bonding. This is the example of non-ionic detergent. Let us now discuss a brief again what is the difference between soap and detergent. In the structural difference, the salt, so in the case of soap, the salt consisting of conjugated base of fatty acid and metal ion. Whereas in the detergent, it depends on the type of the detergent, that there will be fatty acid, but what will be the head group, that will be different case to case. In the soap, soaps are produced from vegetable oil or the animal fats, whereas detergents are synthetic. Those are being synthesized by different chemicals, by choosing the different chemicals. Soap, it has hydrophilic head, that is of carboxylate ion, and detergent has hydrophilic head of different functional groups. Okay, different functional groups. In the properties, how it is different, soaps are biodegradable because the source is biomass for manufacturing the soap. So soaps are biodegradable, but detergents are less biodegradable because those are synthetic in nature. Soaps form insoluble precipitate or scum in the hard water environment, whereas detergent, they form soluble precipitate or some dispersion of um, dispersion of the precipitate in the water environment. So it has better cleansing action. Soap cannot be used in the acidic solution due to the protonation of its hydrophilic head, but detergent can be easily used in the acidic solution. raw materials of the detergents. So we can quickly discuss again. One is surfactant, second one is the straight chain of alkyl benzenes, third one is fatty acid or fatty alcohols, inorganic materials like oleum, caustic soda, various sodium phosphates we need to use. We use the builders and additives. Now, a brief introduction. What is surfactant? We already discussed that what are the how the surfactant that we usually use in the soap and detergent manufacturing. This is the main ingredient. So how the surfactant causes the lowering of surface tension, and there are various kind of surfactants like cationic, anionic, non-ionic. So we will be discussing a brief again. Surfactants are the substances that creates self-assembled molecular clusters, that is the micelles in the solution, and adsorb onto the interface of the solution and a different phase. To show these two physical properties, a surfactant must have a chemical structure with two different functional groups with different affinity within the same molecule. One should be hydrophobic, one should be hydrophilic, and that should be within the same molecule. Usually, the molecules of the substances called surfactants both have alkyl chain that has almost 8 to 22 carbons are there. Alkyl chain. Okay, this chain is called the hydrophobic group or the hydrophobic tail, and they do not show any affinity towards water. The surfactant molecules also have a functional group that is called the hydrophilic group that has a special affinity towards water. This kind of structure with two opposite functions when will be there in the same molecule, that will be amphiphilic structure. That hydrophilic, hydrophobic, both groups are there in the same molecular structure, then it will be called amphiphilic structure. Surfactants are classified into ionic surfactants as well as non-ionic surfactants. Ionic surfactants are subclassified into anionic surfactants, where the hydrophilic head group will be dissociate into anions when in the aqueous solution. Whereas the cationic surfactants they dissociate into cations, and the amphoteric surfactants they dissociate into anion and cations depending on the pH of the solution. Whereas in case of the non-ionic surfactant, these surfactants do not dissociate into ions in the aqueous solution, and they are subclassified depending on the type of the hydrophilic group present. So, what are the additives and builders? Those are used in formation of the detergents. Builders are essential compounds in detergent manufacturers that significantly enhance the cleansing properties. Their primary role is to soften the water by binding with the calcium magnesium ions in the hard water that those are present, which generally are very responsible for the water hardness. By sequestering or precipitating the calcium and magnesium ions, builders prevent them from reacting with the detergent, forming some insoluble precipitates, soap scum, that reduces the cleansing efficiency. Whereas, what is the role of builder then? Then builder helps maintain an alkaline environment which is optional for which is optimal for a cleaning process. The alkalinity aids in the emulsification of the oils and grease. Builders help keep loosen the dirt particles suspended in the wash water and preventing them from redepositing on the fabric. Some builders create an environment that is conducive to the activity of enzymes used in the detergent, boosting their cleansing power. Common types of builder used, one is phosphates, zeolite, citrates, carbonates. These are some common types of builders. Phosphates, these were once widely used but have been phased out in many regions due to environmental concerns. They are highly effective for water softeners. Zeolites, those are aluminosilicate minerals that is effectively that can remove the calcium and magnesium ions from the water. Citrates derived from the citric acid. Citrates are biodegradable and environment friendly builders. Carbonates like sodium carbonate or soda ash, these are very common builder, contributes to the alkalinity and water softening. Some other additives and builders, you can see foam boosters that increase the amount and stability of the foam. Suppressor that controls the excessive foaming. Thickening agent that increases the viscosity of the product and giving it a desired texture and consistency. Perfumes. It marks the unpleasant odors and add more fragrance to the detergent. Dyes. It provides some color to the product. Conditioner. It softens the fabrics and reduces the static cling. Brighteners. It absorbs the ultraviolet light and re-emit it as a very visible light, making fabrics appear whiter and brighter. Preservatives prevent the microbial growth in the product. Corrosion inhibitors protect washing machines or any kind of corrosion. For that, we have to use the corrosion inhibitors. Enzymes, biological catalysts break down specific stains like protein, fats, and starch. They enhance the cleansing performance and especially in the low temperature washing. Bleaching agent. Bleaching agent like oxidize the stains and turning them colorless. Examples include chlorine bleach or oxygen based bleaches. So these are some additives and builders. Those are used in detergent manufacturing as well as some soap manufacturing. So this gives the more um, more add-on features to the soap and detergent. Now let us quickly discuss about the methods of anionic detergent manufacture. We will be discussing about the okay. First, we will discuss about the methods of detergent manufacture. One is the sulfated fatty alcohols type detergent production. Again, anionic type detergent. So this is the first method we are going to discuss, sulfated fatty alcohol type detergent production. It, it involves two steps. Step 1 is the production of higher molecular weight alcohols. And second step is the sulfation of the higher molecular weight alcohols to produce detergent. Okay, so let us learn one by one. So step 1 is production of higher molecular weights alcohol. It involves catalytic hydrogenation of the oil. It occurs at a very high pressure, 100 to 200 atmosphere and high temperature condition of 200 to 300 degrees Celsius. And in the presence of the copper salts at catalyst, the hydrogenation of the oils take place. Hydrogenation oils means it produces the hydrogenated oil that all the double bonds get saturated. Second step is the sodium reduction of that oil. So these high molecular weight alcohols, the raw material here is the coconut oil. So first is catalytic hydrogenation is done in presence of the copper salts at catalyst. Second one is the sodium reduction of the oil. Esterifying alcohol, that is the one kind of amyl alcohol, in the presence of the molten sodium, and those are added to the hydrogenated oil in a aliphatic solvent. Okay, so this is the overall process. Now I will be showing you the reaction involved in the overall step 1. It produces only the high molecular weight alcohol from the coconut oil. You can see this is the alcohol. It reacts with sodium reduction is happening and it forms the sodium salt and some active hydrogen. Now this active hydrogen will react with oil, that is the triglyceride. Okay, it will react with the triglyceride and by this reaction it will form ester. Okay, so this is the ester formation. This one is the triglycerides oil. Okay, so further it is hydrolyzed in presence of water, so it forms fatty alcohol. Ester to in the presence of water it will form fatty alcohol. So there will be three alcohols, 1, 2 and 3. There will be three fatty alcohols and there will be propanol. Sorry, there will be glycerin. Glycerin. Okay. The next step is the sulfation of that alcohol to produce the detergent. An excess amount of 98% H2SO4 acid, sulfuric acid, or the oleum is added to purify the fatty alcohols. Acid sulfate is converted to sodium salt. The excess sulfuric acid will be neutralized and the sodium sulfate is dried. Okay. So overall reaction is this is the alcohol. It reacts with the sulfuric acid and then it reacts with NOH. So this is ultimately the detergent. The second method is the alkyl aryl sulfonate type detergent production. It involves four stages. Step 1 is the paraffin is separated from the petroleum feedstock. Here we are using the petroleum feedstock. From there, paraffin is being fractionated. Petroleum feedstock, from the fractionation of that, the paraffin is being separated. Second step is paraffin undergoes the chlorination reaction to produce the alkyl chlorides. Alkylation reaction of the alkyl chlorides with benzene to produce the aryl benzene component. And last step involves the aryl benzene component which reacts with oleum to produce the aryl benzene sulfonate. This is the widely used anionic detergent. So let us quickly write down the chemical reactions involved. Suppose this is the paraffin, general structure of paraffin. Okay, it reacts chlorination reaction and it produce the alkyl chloride and HCl. Okay, the second step, what I have told, it reacts with the benzene. This alkyl chloride will react with the benzene in the presence of AlCl3 catalyst, and it forms aryl benzyl component, and this one will further go down with the presence of H2SO4 and SO3, that is the presence of oleum. It forms the aryl benzene sulfonate. This is the aryl benzene sulfonate. Let's discuss about the glycerin production. That will be the last topic of this session. The glycerol production or glycerin production. See, this soap and detergent whole industry produces lot of glycerin, and that is a huge amount of glycerin you can produce. So that is a very good feedstock for further processing of various kind of chemicals or soap or detergent. Okay, so now what is glycerin again? Natural glycerin or glycerol is produced by the natural process. Naturally, it is produced by the hydrolysis of the triglycerides, means fats or oils. Glycerol or glycerin is 1,2,3 tripropanol. That is, a structure is like this. The structure of glycerol. Okay, this is the 1,2,3 tripropanol. Glycerin is used in industries such as explosive, food industries, pharmaceutical, alkyl resin, plastic. And now the main concern is we also synthesize the glycerin by other chemical reactions. Though synthetic glycerin is produced from the propylene uh, that is obtained from the petrochemical processing. There is various route. We will be discussing about two main routes, that is the allyl chloride route and another one is the acrolein route. So first one, that is the synthetic production of glycerin. One is the allyl chloride route. So they involve multiple chemical reactions step by step. So let us write down one by one. First one, yeah. First one is propylene. It will react with chlorine by chlorination reaction around 400 to 500 degrees Celsius, and that will form the allyl chloride and also HCl. This allyl chloride, it will further react this one, this one in the addition of this will produce CH2OH, CHCl, CH2Cl. So this is the glycerol dichlorohydrin. Glycerol dichlorohydrin is again react with in the presence of CH, this one, it forms the epichlorohydrin. Epichlorohydrin, and the last part is in addition with the NaOH and water, it forms the glycerin plus NaCl. So this is the source of petroleum product, propylene, chlorination reaction. It forms the um, allyl chloride This allyl chloride forms glycerol di glycerol dichlorohydrin. This is called AP hydrin, and last one it forms the glycerine. So this is the method of propylene to glycerin by this allyl chloride route. Second one is the acrolein route. Second one is the acrolein route. Again, the reactions involved is first the source is propylene. It is hydrolyzed and it forms, that is the isopropanol. Okay. Now this isopropanol, it reacts with oxygen at a certain pressure and temperature condition to atmosphere, and it produces acetone. It produces acetone and hydrogen peroxide. This acetone, again this propylene, that is CH3CH11CH2, this propylene acts with oxygen and that gives acrolein. This gives acrolein plus water vapor. Presence of CO2, 350 degrees Celsius, 1 to 10 atmosphere. Okay, so this acrolein will further react with this acrolein will further react with isopropanol. In the presence of some catalyst, MgO catalyst 400 degrees Celsius, it forms allyl alcohol plus again acetone. Allyl alcohol, it reacts with hydrogen peroxide in the presence of this catalyst at 60 to 70 degrees Celsius. It forms glycerol. This is the glycerol. In the whole process, so this is the propylene isopropanol and acetone is being produced. Again, propylene, acrolein, via acrolein, it is producing, allyl alcohol. This one is the allyl alcohol, and again it produces the acetone. And ultimately we are getting glycerol. So there is a in this process, um, you have to this process there is a huge product is acetone. Okay, so there are other chemical reactions are involved in other processes by which we can produce the glycerol. So that's all for today's class. Yeah. So in this class, we have briefly discussed about what are the properties of the soap and detergent, and also their action mechanism, the different types, how the soap is being different with detergent, and then discussed about the process flow, continuous process of soap production as well as glycerin production out of the uh, same manufacturing plant. Also, in the detergent manufacture, we have also discussed various methods for producing the unique detergent. Discussed about the glycerin, that is the main backed by hydrolysis of the triglyceride. This glycerin production is very huge market that we get from the soap and detergent industry. How it is being produced by synthetic method, that has been discussed at the last of this session. So we all over covered the soap and detergent industry in all possible way. So hopefully this session will be helpful for you to get the basic understanding about the process involved and the features, properties, mechanism of acting, um, their importance, significance, and those things. So, apart from the NPTEL lectures, if you have any queries, then you can refer to this video. Hopefully, uh, you people will be joining in the next session. There, we will be covering other industry as well in our future sessions. So that's all for today. We will be meeting in the next session next week Friday, 7 to 9 p.m. slot. Thank you. We will meet in the next session.